So our assignment topic is about the escape velocity. Me, Junyi, will be saying for the introduction. Nikolai will be saying aspect 1 and aspect 2. Shanhang will be saying for the aspect 3. And Tian'e will be saying for the conclusion. So escape velocity is the minimum speed required for an object to escape from the gravitational attraction from a planet. So for our assignment, there is 3 aspects which might affect the escape velocity. For the first one, which is the angle of the projection. For the second one, the height of the object being projected. And for the third one, the changes of the weight.
Let's begin with a look at the first aspect affecting the escape velocity, which is the angle of projection. As we found out, there is no relation between the escape velocity and the first aspect. That's because escape velocity itself is a speed requirement for an object to leave the surface of planet, star or satellite. Therefore, speed is a scalar quantity which won't affect the final value. We can also verify this by solving a simple problem. Here's our problem. It's problem A. So the mass and radius of the star are given, and in parts 1 and 2 of projection angles of the rocket from the surface are given. We use the escape velocity formula to solve, and we can see that the final value does not change for both of the questions, uh, for angle of 45 degrees and for angle of 90 degrees, which confirms our theoretical proof. Solution for part B is almost same, only the data differs as our starting point now is planet Earth. So we just merge the part 1 and part 2 as our solutions will be the same, and we can see that it's possible again to confirm the theory. So the answer is 11.55 km per second. Now let's move on to the second aspect, which is the height of the object being projected. As our formula will be affected and the radius between the rocket and Earth will increase, here you can see, slight difference in denominator decreases the final value of escape velocity. For next one, solve we solve two problems. For question A, part 1, we just insert the values into our formula. We have to mention that this formula escape velocity is basically square root of 2 multiplied by g and m, where g is gravitational constant, m is the mass of the planet or satellite or a star, and radius is the radius from the middle point to the object being projected. So we just insert the values and obtain the result, which is 365.34 km per second. For the part 2, we again insert the data into the formula, but we make the slight change in the denominator by adding the height of a platform from which rocket is being projected radius. Receive the result, and it's slightly lower. Part B is basically the same, it's straightforward, so we put the data into the formula again, and we will receive the answer, which is 11.55 km per second. Part 2 of this question is also the same, but we're adding the h. So the result is slightly lower as our denominator decreased by h.
I will be talking about aspect 3 changes in mass. So will the changes in mass affect the escape velocity? We need to know that how we gonna find the escape velocity is actually by the conservation of energy, which is the kinetic energy, to the gravitational potential energy. And from this equation, we know that the smaller case m represent the mass of the object, then the bigger case of m is the mass of the celestial body. So actually, from here, we can cancel out the mass of the object, which means the mass of the object will not affect the escape velocity. Let's turn to the question in aspect 2. As we know that the changes in mass of the object, it won't affect the escape velocity. So from here, we just need to use the formula and we plug in the value. G will represent the gravitational constant, m will be the mass of the celestial body, and r will represent the distance between the center of the celestial body to the surface of the celestial body. And here will be the value. For part B of this question, we changes the celestial body from star to a planet, but it's actually the same method as part A, but we need to change the value inside. We apply the formula, the escape velocity formula, and we plug in the value. G will represent the gravitational constant as usual. The m will represent the mass of the celestial body of planet X, and the r will be the distance between the center of the planet X to the surface of the planet X. And here will be the value.
To conclude, the aspects that did not affect escape velocity are the angle of projection and the mass of the object. The aspect that will affect escape velocity is only the height of the projection. Thank you for listening.